How's it going, geometry class? Today we are going to talk about 4, 5 isosceles and equilateral triangles. Now, why did I put these on different pages of the world? I never know. Okay, an isosceles triangle is, well, what is it? It's a triangle with two congruent sides. That's all this. Isosceles triangle with two congruent sides. If you look at the word isosceles, iso means equal. Celes is actually Old Greek, which means legs. So equal legs. So again, two congruent sides, and that's why the two congruent sides are called legs. The side that's not congruent is your base, and your base has two equals called base angles. And your vertex angle is one in between the legs. So if I were to redraw this, oh come on. If I were to redraw this like so, I'd say these would be my two congruent legs. This would be my base angles, vertex. Okay? Alright, moving on. We have an isosceles triangle theorem now. What it basically says, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay. Opposite means they aren't touching. There's an angle touches two of the sides. The side it does not touch is the opposite side. So, for example, if AC is congruent to BC, isosceles triangle, the angle opposite of B, or of CB, is angle A. So that means angle A is congruent to, well, the angle opposite AC is B. Okay, so your base angles are congruent. Okay? Okay. There's a converse of it. You know what the converse says is, if your base angles are congruent, then the opposite sides are congruent. So the ones that are looking at, so like that tells me that A is looking at this side and B is looking at that side. Okay? So pretty much, if you know base angles are congruent, you got an isosceles triangle. Two of the sides are congruent. Two of the sides are congruent. Their two opposite angles are congruent. Ta-da! Okay, we're going to get tricky. Is WVS congruent to angle S? Is TR congruent to TS? Okay, let's try this out. So, WVS congruent to angle S. Well, if we look right here, these two sides are congruent, right? If these two sides are congruent, means that opposite angles are congruent. So, yes. Okay? And that is by that isosceles triangle theorem. Okay? Now the second part is TR congruent to TS. Well, TR is this whole length right here, right? TS is this. Well, we look at these angles. Is S congruent to R? Yes. Since angle R congruent to angle S, then TR is congruent to TS by the converse. Of isosceles triangle theorem. Ta-da! Now B, can you say that RUV is an isosceles triangle? Well, we have one angle and no sides. So, no. you either need two angles congruent or two sides congruent. And we only have one angle. Capiche? Capiche. Speaking of all these triangles, did you guys hear what the triangle said to the circle? The triangle said, your life is so pointless. Think about it. Okay, we got some more theorems. Theorem 4, 5, which we're just going to not name. If a line bisects the vertex angle of an isosceles triangle, then the line is also perpendicular to the base. So what it says is if you cut this angle in half, and you know these two sides, so you know it's isosceles, and you cut this angle in half, then you know this is perpendicular and a bisector. Okay, cut the angle in half, you cut the side in half for isosceles triangles. Okay, cut the angle in half, cut the side in half, right angle. You will prove this in 4 5 in exercise 2.6, 26. Okay, what is the value of x? Well, this 54 actually goes here. So first thing I'm going to have to notice is, well, ADB is going to equal 90 degrees. How do I know it? This is an angle bisector, so it means that these are going to be right angles, right? Okay. So that's 54 degrees and that's 90. How do I find this angle? I'm going to go 180 minus 54 minus 90, which is going to be 36 degrees. Now if this is 36 degrees, this angle is also 36 degrees. So x equals 36 degrees. It's pretty cold though. Not quite freezing though. Okay. Corollaries. Corollaries. What's a corollary? Corollary is a theorem that can be proved easily by using another theorem. Okay. You don't call a theorem because it's, well, it is a theorem, but it's just one that you can make up really quick. Like, if a triangle has 3 equal sides, then all of the angles are congruent. And not only that, I'm going to add this since they're triangles. It also equals 60 degrees. Because what's 180 divided by 3? 60. So equilateral triangles all have all angle measures equal to 60 degrees. And all sides are congruent. Now, in reverse, if all your angles are congruent and they all equal 60 degrees, then it's an equilateral and all sides are equal. Now I want you to think about this, ponder this. If two angles of a triangle are 60 degrees, what does the third have to be? That's right, 60. So it has to be an equilateral triangle. Something to think about. Enjoy the rest of your days.